Okay, the first example asks us to calculate the mass percent of a solution containing 27.5 grams of ethanol and 175 ml of water. We have to assume the density of water to be approximately 1 gram per ml. So we know that we want to use, because it's asking for mass percent, we want to use the formula of mass percent being equal to the mass of the solute divided by the mass of the solute plus mass of the solvent times 100. So what is our solute? It's going to be the ethanol, because if you recall, the solvent is the majority of the solution, which is going to be water, and water is a very, very common solvent. And our solute is ethanol in this case. So we just plug in our values. 27 grams of ethanol over the 27.5 grams of ethanol plus, what is the mass of our solvent or water? We don't have a mass here because remember the units of mass are gram. We have 175 mils of water, but since we're given the density of water, we can figure out how many mils. So let's do that as a side note here. Okay, our 175 mils of water, we know that because for every 1 gram of water, we have 1 milliliter. So since milliliters is on the top, I'm going to put milliliters are on the bottom here. For every 1 mil of water, I should have 1.00 grams. So remember that density is a conversion factor between mass and volume. And so this is simply 175 grams of water. So now I can plug in 175 grams, and this is times 100. When I plug this in, I end up with, let's see, 13.6%. And that is my final answer. Okay, now you go ahead and you give this a try. Calculate the mass percent of a sucrose solution containing 11.3 grams of sucrose and 412 ml of water. Again, we have to use the formula of mass percent of solution, which is defined as the mass of the solute over the mass of our solute plus the mass of our solvent, and this is times 100. So let's define what my solute is. In this case, it looks like my solute is going to be sucrose, 11.3 grams of sucrose. My solvent is water. So 11.3 grams over 11.3 grams of sucrose plus the solvent, the mass of the solvent. Again, notice that this is in milliliters. This is a unit of volume, so we have to convert it to to mass. And what is that conversion factor? The density of water. So if we have 412.1 mils of water, we know that for every 1 mil of water, I have 1.00 grams of water. So we have 412.1 grams of water this way, because my mils cancel out and I'm left with grams of water. So now I'm able to plug this in over here. So 412.1 grams, and we take this and multiply it by 100. You should have gotten 2.67% of sucrose in solution by mass. Okay, now we're going to see how we can use mass percent in calculations. We can use the mass percent of a solution as a conversion factor between the mass of the solute and the mass of the solution. And so let's see how we do that. If we have a water sample from the bottom of Lake Nyos containing 8.5% carbon dioxide by mass, then how can we determine how much carbon dioxide is contained in 28.6 liters of water solution? And we are given the density of the solution to be 1.03 grams per mil. That's slightly different because this is salt water, so it's not pure water. But again, we just give you the density of the solution. So we would want to start out with what we're given. We're given 28.6 liters of water in solution, and we want to figure out how much carbon dioxide is in there. But we know the mass percent. So let's see how we can use the mass percent. First, what does 8.5% carbon dioxide by mass means? It means that we have 8.5 grams of CO2 for every 100 grams of solution. Okay? With that being said, you see how that's a conversion factor. Let's see how we can relate it. If we start out with 28.6 liters of water, we want to go from liters to milliliters first, because we want to use the density as a conversion factor, but the density here is given in grams per milliliter, not grams per liter. So our first step is we have to convert the liters. For every 1 liter, I have 10 to the third milliliters. Now I can use density as my conversion factor to go from milliliters to grams. And I know here for every 1 mil of solution that I will have 1.03 grams of solution. Finally, now I can use this conversion factor here. And this is telling me for every 100 grams of solution, the reason why I put that on the bottom is because I have grams of solution on the top here. So I'm going to put grams of solution on the bottom. But remember, I can reverse these in any way that I want. For every 100 grams of solution, I have 8.5 grams of carbon dioxide. Okay? So that's exactly what I'm looking for. I'm looking for the how much carbon dioxide in grams. So I'm done. I don't have to take this any further. You see how my liters cancel, my mils cancel, my grams of solutions cancel, and I'm left with grams of carbon dioxide. When I plug this in, I get 2.5 times 10 to the third grams of carbon dioxide in solution. Okay, so you go ahead and you give this a try. You have a soft drink that contains 11.5% sucrose by mass. What volume of soft drink solution in milliliter contains 85.2 grams of sucrose? And the density of the solution is 1.04 grams per mil. So you have one conversion factor between grams and mils here for your solution. What again does 11.5% sucrose by mass means? It means for every 11.5 grams of sucrose, I have 100 grams of soft drink. So I'm going to call that SD. So soft drink. Okay, so that's my other conversion factor. Now let me start with what I'm given. I'm given 85.2 grams of sucrose, and I can go from grams of sucrose to grams of soft drink using this conversion factor. For every 11.5 grams of sucrose, I have 100 grams of water from this definition here, okay? But this is asking me what is my volume of solution, and this is my mass in grams. So I have to take it one more step by using my second conversion factor that says for every 1.04 grams of solution or soft drink, I have 1 milliliter of soft drink. And so I'm done with that. You see my grams cancel, my grams of soft drink cancel a solution, and I'm left with milliliters of soft drink. I plug this in and I should get 712 milliliters of soft drink. Okay, now how much sucrose in grams is contained in 355 milliliters, or this is your 12-ounce can of soda of soft drink. Okay, again, you want to start out with what you're given. You're given 355 milliliters of soft drink. Okay, and so how do we go from milliliters to grams of soft drink? We use our density. For every 1 ml of soft drink, I have 1.04 grams of soft drink. Now I can use the second conversion factor to go from grams of soft drink to grams of sucrose. I know since grams of soft drink is on the top, I'm going to put that here on the bottom, and my grams of sucrose is going to go on the top. Okay, and I know for every 100 grams of soft drink here, I have 11.5 grams of sucrose. Okay, and so this is done because I'm being asked how much sucrose in grams do I have. The mils cancel, the grams cancel, and I'm left with grams of sucrose, which is my desired unit. Okay, so I should get 42.5 grams of sucrose is contained in 355 mils, or a 12-ounce can of soda has 42.5 grams of sugar or sucrose. Okay? Do more example problems if you need to understand this concept.